Hi there. Today I will be solving valid palindrome. It reads, given a string, determine if it is a palindrome considering only alphanumeric characters and ignoring cases. For the purpose of this problem, we define empty string as valid palindrome. Example 1 is a phrase reading a man, comma, a plan, comma, a canal, colon, Panama. If we were to disregard the non-alphanumerics, that is the punctuation and the spaces, and also overlook the difference of casing, that is the lowercase or uppercase, and this is a perfectly palindromic phrase because A matches to A forward as backwards, and M to M, and so on and so forth, and until both the forward and backwards meet at the midpoint. So that is true. The next example, however, we see a E in the first word, but in the last word we don't see a E, so there's an inconsistency there. So that's a false, that's not a palindrome. So one of the constraints is that we're told S consists only of printable ASCII characters. Just want to point that out. So that's what they look like, ASCII characters, basically capital and lowercase alphabets and numbers and some special characters. So just a way that they're represented in a computer, that each character is given a certain number to account for that character. So that's all that is. Now, in terms of this question being relevant in tech interviews, companies such as Facebook, Apple, Microsoft, Bloomberg, Amazon, and many others do ask this question. And the related topic in this question is strings and 2 pointers. And that brings me to my solution. So let's take a look at it. So I'm going to be showing 2 approaches, one of which I'm going to be walking through over here. So a palindrome is a word, phrase, or sequence that reads the same backwards as it does forward. Take the word mom or madam, they both read the same both ways. Now that brings about an insight in my mind, is that any word and its exact reverse, both put side by side, they make a palindrome. So take the word hey, for example, spelling H-E-Y, and its reverse is Y-E-H. When they're concatenated or put together, it spells hey. That produces a palindrome. So the idea then is, when we reverse the input string and compare it with the original, and if they both happen to be equal, hey, we've got a palindrome. And this is what the algorithm here is for. So we have the valpal function, and it takes our string, input string S, and what we want to do is get it ready for the palindromic check according to the problem description, which said to consider only alphanumerics. So to disregard all the non-alphanumerics, what we do is use the dot replace helper function. Inside of that helper function, the parameter we pass in is what's called regex, or regular expression. Now it occurs to me that this usage of regex intimidates, confuses people, and it just seems foreign and intimidating. It doesn't need to be. It's simply a way to pattern match. And because we're only interested in alphanumeric characters, that is characters consisting of alphabets and numbers, this is what we're specifying inside our regex syntax. So anything inside the bracket, we're saying basically, hey, regex, pattern match me with only these things. That is alphabet in the range of A to Z and numbers in the range of 0 to 9. And the IG here, G is basically for globally matching, that is looking at this pattern across our input string. And I is basically for in case sensitive, that is, give me these set of alphabets irrespective of it being upper or lower case. So that readies our string for alphanumeric characters. And then we give it a case. So we make it 2 lowercase, and that's what this function is for, as the name suggests. So now, once we do this, our string is ready for having the palindromic check. So this readied string, we put it into the str variable. So this string is referenced inside our str variable. Now below the line, the code below basically addresses our base case, which is that if we're given a string that is null, doesn't have anything, or if the string only has 1 character, that would be a true palindrome, because having nothing is equal to itself, nothing, and then having just 1 character is also equal to itself. So that's true. And then really at the heart of the idea, we see this code that the original input string, if it's hey, right, then what we want to do is split that hey a string into individual elements, and then reverse those individual elements and then join them together. Now, if the reversal of that input string hey a happens to be the same as our input string, which is hey a as well, then hey, that's a palindrome, and we return true. If even in one case that we see inconsistency, that they don't match the input string and the reverse, then it's a false. So it's a pretty straightforward algorithm. So as legitimate as it seems, which it is legitimate, but it's a costly solution, and unnecessarily so, because this can be done with traversing the input string twice, as I'll show in my other approach, which is using 2 pointers. This approach requires the input string to be traversed thrice, and it also requires additional space to store, filter, and reverse the string, so that both the time and space complexity end up being of n. And we can avoid that. So let's take a look at how so. Okay, so here is my second approach, which uses 2 pointers. And like we've seen in the first solution, I have this, first of all, I have this function valpal, and its parameter is my input string str. And inside of this function, first we get the string ready for the palindromic check, like we've seen in the previous solution, right? Replace all the non-alphanumerics with only alphanumerics and make it lowercase. That's ready. Now what we do is, to traverse our input string, we use a for loop, and because we're using 2 pointers, by the virtue of using 2 pointers, we're going to be traversing both halves of the string at each iteration. So I have my example input here, madam, and what happens is that when I use 2 pointers, which I've named here the variable start and end, those are my 2 pointers. So start starts with the first index, the first element, and end starts with the last element and the last index. So what happens is start increments forward and end decrements backwards, and their aim is to meet at midpoint. So what it does is, like, the start and end, they're coordinated. They act like a coordinated pair, like, hey, do we have the same thing? Yes. And then they both proceed, they're on one more step until they both meet each other at the midpoint. And for that reason, we don't need to traverse all of the element in both directions. We don't need to do that. That's just redundant. So let's walk through this, and we can see how this may look like. So I have my input string madam, and I'm going to be traversing from the starting, which is I equals to 0, until the midpoint. Now I have written the index number underneath my input string, just to kind of help visualize how the traversal is happening. So start variable, like I said, is the first element, and end variable is the last element. And I just want to point out that the str of str.length minus 1 minus I, it looks wordy and weird, but really that whole denotion inside the bracket is just representing an index, a number. Str.length, what is that? Well, 5, because the word madam, my input example, is 5 words. So it's 5. We give it a minus 1 because this input string, it's a string, it's placed inside an array, and each individual character of that string is individual element inside of that array. Because arrays are 0 indexed, we have to consider the length minus 1, because we would do 0, 1, 2, 3, 4. So in array of 4, we would have the last element, and that's what the need for minus 1 is. So our length is 5, minus 1 gives us 4, minus I, which is 0 starting. So that is str of 4. At str of 4, we see the letter M. I just wanted to clarify that so it doesn't throw people off as this long weird thing. Anyways, if str does not, if start does not equal to end, which means at any one point or both pointers don't have the same character, then that immediately disqualifies the palindrome. It disqualifies the string as being palindrome, and we return a false. But if at every iteration both the pointers have the same character until they meet in the middle, then that's perfectly palindromic. Now let's walk through this real quick. So start, right, when I equals to 0 initially, right? So start is str of I. We get the letter M. And then end, which is str of 4, we also get the letter M. Both are equal. Good, continue. Now at str of 1, we get the letter A for start. And at str of 3, we get the letter A also. So far so good. Now we come to our midpoint, which is str of 2. Oh, sorry. So when at str of 2, we see the letter D. And then str of 2, which is the end, that's also D. So what we're seeing now is that start and end now overlap, they meet each other. So all of the characters have been same. That means our palindromic string is true. So this solution has a time complexity of O of n and space complexity of O of 1, because we don't have to use additional space. So it's O of 1, and the time complexity, where we're just traversing the string really 2 times, one to replace the alphanumeric characters and the other time to loop through and see if both the pointers have the same characters. So I think the key feature of this solution is that we're optimizing. There's an opportunity for optimization by dividing the length by 2. So basically both the pointers, the first pointer, the start, is incrementing forward, and the end variable is decrementing backwards, and they both meet at end point. So by the virtue of using 2 pointers, they're both checking, each iteration is checking 2 letters at a time. So with the by default, we'll be checking the whole string by just coming to the midpoint from both sides. But if we had the length, basically if we traverse the whole thing, what we're doing is doing it again. So we would be traversing, start would be going all the way until it goes to the end, and end would be going all the way until it comes to the front. And that's pretty redundant, so there's no reason to do that. So for that reason, we optimize it, and really you want to be able to think if you can make such optimizations. Now let's run this on LeetCode. Okay, so I have the solution here, and the only change really is that I use the input letter S instead of str, and basically it's otherwise the same. So let's submit it, and there you have it. Again, I always mention I think the runtime here is far better than what shows here. It's a pretty optimized solution, especially with having the length divided by 2. But as always, LeetCode has to give me a wrong runtime. Anyways, should you have any questions or comments, let me know down below. And if you found me informative, please subscribe and like the video, and let me know if what else you like me to cover. Thank you.